So can you able to see my screen, guys?
Yes, sir.
So here it is. We discuss about what is an IP address and IPv4 and IPv6. At least find out some differences which you can easily tell. Okay. Again, IP addresses and classes. IPv4 is divided into 5 classes. The total IPv4 is from 0.0.0.0 to 255.255.255.255. This is a total range. So from this to this end, it is 4.3 billion IP addresses. So total 4.3 billion IP addresses are divided into 5 classes. Okay, so 5 parts. But how it is they divided based on the first octet of the IP address, means first part of IP address. 4 parts of IP address, the first part of IP address. Okay, so class A is the range is 0 to 127. Okay, so if your IP address, you have seen an IP address and you see the first octet, okay, and check the range is in between 0 to 127. It is a class A IP address. Like that we can identify. Of course, for a class A, if you check in a certain website or a test some books, it may show 1 to 126. There is a reason, because of the 0.0.0 is a reserved IP. It's also called as unknown IP address, and also in certain services we use this 0.0.0 service like a default routing in a routing concepts, like a default routing concepts, and DHCP. When a client is getting an IP address, so for client use this IP address as a source IP address in different places also. So it is called a reserved IP address, or we cannot assign this IP address to a host. You take a computer, you can't assign this 0.0.0.0 IP address, as well as anything start with a 0. The first octet is 0, so it won't accept it. Okay, so next one is 127.0.0.1 is a reserved IP address for a local host or a loopback address kind of stuff. So every PC itself IP address is self IP address is 127.0.0.1. Like normally we assign an IP address to your NIC. Okay, we assign an IP address, we open NIC and we give an IP address, right? Or you got an IP address. So that is based on the network, you have an IP address. But every PC has its own IP address, is a 127.0.0.1. Just before I explain here, like this. So here it is a EPC is there. So this EPC installed with a Oracle database in the EPC. Okay. So from EPC means I open my EPC. I was in the EPC. I want to communicate. I want to access this Oracle database through some application, like some client application. I want to access Oracle database. So what IP address I can use? Very simply, like a 127.0.0.1. For example, I have another computer in the network, in same network. I have another computer. For example, APC is there. From APC, I want to access Oracle database, which is in the EPC. So how to access from A? So I have to use EPC IP address is 192.168.1.37 IP address, not 127.0.0.1. So that's the difference. Like one PC to another PC communication, we use the regular IP addresses. For a self communication, you can use 127.0.0.1. That is a local host or a loopback IP address. It is also for self-testing purpose. Like for testing TCP IP is working or not, like that. Okay. So and also we don't use 127 entire series. So start with 127. So remaining can be anything. We cannot assign to any adapter. So that's why it is showing 1 to 126, but original range is 0 to 127 only. Okay, but for assigning to any PC, we cannot use 0 series and 127 series also. Next, class B 128 to 191. Okay, class C 192 to 223. Class D 224 to 239. Class C 240 to 255. So yesterday we discussed about OS layer. Now it is IP address classes. It is similarly like there is a 7 names are there. Here 5 ranges are there. 5 ranges are there. So you have when you are at a time of interview, or maybe while you are working. So maybe internal interview or by our interview, you got a question. So what? Tell me about 7 layers of OS layers, or tell me about classes and their ranges. How to tell? How to remember all these things? Only thing is, guys, read repeatedly, keep telling repeatedly. Okay, so that's the main point here. It is later we can understand, we can find some logic inside, so we can able to tell. Okay, and class A, class B, class C are unicast IP addresses. IP addresses from class A, class B, class C we can assign to any device like a PC, laptop, tablet, and so anything we can use class from IP addresses from class A, class B, class C only. Class D IP addresses are multicast IP addresses. This range of IP address like 224 to 239 range we cannot assign to any of the PC, any of the devices. It is used by certain protocols like a routing protocols like a RIP version 2, EIGRP, OSPF kind of protocols use, or by installing operating system through network. BootP protocol use this multicast addressing. Okay, like you want to deploy an application to multiple devices, we use backend multicast addressing. Multicast means like a WhatsApp group type means, okay, group messaging type. Okay, sent to a particular group which following same protocol. Okay, EPC, sorry, class E is a 240 to 255, which it is not released into the public. Maybe it may use in some places, but not in any public or private communications. Okay, so when you see an IP address, to identify the which class of it is, whatever it is in the second and third, fourth positions. Okay, first position is important, not remaining things for identification of classes. So here it is, if you see it's a 120 is we have to look at not a 209 or 120 is a first octet part. First octet is 120. It is a range in between 0 to 127. It means it is a class A. Already I explained just before. Okay, that's why I'm telling directly. Okay, so if you see an IP address like a 150 or 151, it is range in between 128 to 191. It means it is a class B. 197, it means it's a range in between 192 to 223. It is a class C. 224, it is a class D. Of course, 240 is a class C now. Okay. Yeah, guys, from here again. So in our communication, we use class A, class B, class C only, not class D or class E. Okay. So why we should divide into the classes? Okay, why we should we divide into the classes? Because of IPv4 addresses are very limited, first of all. Second one is based on your network size, we can use which class you want it. How we can divide a network sizes, we can see here it is. Okay, how to define this network sizes, we'll see here it is. The class C, the first 3 portions are network portions, last portion is host portion. Last portion is host portion. Okay. Look at here. Oh. I will come back to that picture again. So we'll see. So I have a computer and I'm assigning an IP address to it. So for example, a class C IP address, example 192.168. Something 10.11, this IP address. Okay. So another PC IP address is 192.168.10.120. Okay. So it is a class C. The first three are network, right? So this is network. First portion is same on NAT. Second portion is same on NAT. Third portion is same on NAT. So these three parts are network parts. Okay, these three parts are network. This is host part. This is host part. So in these two things, network part is same and host is can be different. Like earlier I said one example, right? As a roll number. Okay, so this part is same and this is changeable. Same thing like this is a 11, this is a 120. Okay, so simply you can say like here it's a network portion, then this is the host portion, and I will tell about a number of hosts and all, but understand if it is a class C, first three portions must be same and last portion is different. So then obviously it is both system can able to communicate each other. Okay, so network is different. Similarly, if you take class B, network, host, network, host. I take a one class B example. For one PC, there is a one first PC is 170.16.0.15. And another PC IP address is 127.16.14.25. As I said, class B network, host. Meaning is network portion must be same for both the PCs. Check it, network portion same. First octet, first one is same. Second octet is same. That's it. This is same or not, that is not our mind. So if it both are same, then it is conflict. Both are different means it is okay, no problem. Here it is a 0, it is 14, no problem, host. This is 15, this is 25, no problem, host. But both will communicate each other. How can we decide? First check the network portion. First of all, check whether it is which class of it is. It is a class C. It is a class C. It is a class B. It is a class B. It is class C. In a class C, network, and host. Class B, network, host. Okay. So first of all, identify which class it is. Then go to network portion and host portion. There is a rules are there, rules and regulations I will tell. Okay. So first of all, try to understand. Then if you understand IP addresses, you will understand easily next part. Next, class A. First portion is network, remaining are host portions only. Okay. So here it is. I take 10, 0, 20, it's become different. 22. Okay. 10, 12, 4, 2, 10. Anything, no problem. So it's important is first is a network and host. So network must be same. So both are network portion is same and host portion is different. No problem. Both will be communicate each other. So when two PCs are communicating each other, two PCs are there. if they can able to communicate each other, the rule number is their network portion must be same. Network part is must be same. Okay, then only they can able to communicate each other. Okay, device must be in the same network to communicate each other. Of course, physically they must be in the same network, but logically they must be in the same network. Okay, so how to determine like there are in a same network? How you tell both are in a same network? By looking at their network portion. Check their network portion. If network portion is same, both will communicate each other. Or calculate network ID. Calculate network ID of both the PCs. If their network ID is same, they will communicate each other. Okay. What is this I have written? I will tell. Okay. If in case, if both are different networks, this is different network, this is different network, right? If both are different networks, you want to make a communication between this network to this network. You need a router. Okay. Why we need a router? To make a communication between one logical network to another logical network. Why we need a router? What is the router? Anyone? Anyone? All are busy. Router is a inter-networking device. What is inter-networking? Communication between two or more network
devices, networks.
two or more different networks called a inter-networking. Router is a inter-networking device. This side, this kind of network is there. This side, this kind of network. You want to make a communication between these species in the different logical network. We need a router. Okay. And I draw some diagram right here. It is. So I will tell a story from here. What is a physical network and a logical network? How we can able to divide? Okay, of course, it is a small sizes. I can't put a full IP address like this. Okay, yeah, maybe I will try. Yeah, I will try 1 dot. It's a very simple number. Single digits are better. So 1 dot 0 dot 0 dot 1. This 1 dot 0 dot 0 dot 2. Okay, it is a 1 dot 0 dot 0 dot 4. 1 dot 0 dot 0 dot maybe 10, no problem. 1 dot 5 dot 2 dot 3, anything, because of what is 1? 1 is the comes under class A. The first portion must be same. The 1 must be same here. Okay. Next I started 2 dot 4 dot 5 dot 1. 2 dot 3 dot 2 dot 1. 2 dot 0 dot 1 dot 2. 2 dot 1 dot 1 dot 2. 2 dot 5 dot 3 dot 2. Okay, something I given. See it is how many are belongs to same network we'll write. Okay, see this is can able to communicate this and communicate this, and it will communicate this, it will communicate this like this. So these are all PCs logically same network. Logically same network. Next, these PCs are logically same network, but all PCs are physically same network, but logically different network. That's why IP address is logical addressing. They are divided in logical way, not physical way. Okay, not physical way. They divided logical way. Okay, these PCs can communicate each other. These PCs can communicate each other. Okay. Next, if you have a different logical IP addresses, if you have a two networks, for example, this is a network and this is another network. Okay, so you have a PCs. Just before how I said, like same thing only. This is one physical network, one LAN network, for example. This is another physical network. For example, this is same thing like I put a 1 dot is easy. 1 dot 1 dot 1 dot 1. So I'll put a 2. 1 dot 1 dot 3. 1 dot 4 dot 2 dot 4. 1 dot 4 dot 6 dot 3. Something 1 is common. This is physically and logically divided. So that's keep it in that manner. Okay. 10. 2 dot 1 dot 3 dot 4. Okay. 2 dot 4 dot 5 dot 6. Okay. 2 dot 7 dot 9 dot 4, for example. This is small numbers, right? So two different networks. If you connect like this, then it is become single network only, single physical network. Earlier it is a two different physical networks. Now single physical network, single segment only, single segment, single physical network only. If you are connecting this switch to that switch, but they won't communicate each other. This is won't communicate to this one. What I have to do it to make a communication between this network to this network, connection is not enough. So what I have to use? Internetworking device. What is internetworking device? Router. So this network, if you want to make a communication between, you want to communicate from here to here, you don't require router. But you want to communicate from here to here, we need a router. Okay. So you want to communicate like this. You go to router, reach here and reach here. Or you want to communicate from here to there, like we reach to the router to like this. Okay. We are communicating through router. So one more point also I will tell, that's why I'm telling this story. This router, this side of port, IP address is 1.1.1.1, for example. This side of port IP address is 2.2.2.2. Okay. So here to understand, see it is, if this PC want to communicate this PC, we don't require router, means we don't require this IP address. But if this PC want to communicate from here to here, you want to communicate, you have to go through the router only. Then IP address is 1.1.1.2. Okay. Subnet mask is 255.0.0.0 because it's a class A, and default gateway. What is the default gateway for these machines? This is the default gateway. Okay. This is the default gateway. So that's why first it want to, first of all, this PC 1.1.1.2 PC want to communicate, send a packet 2.4.5.6. Okay, when it is want to communicate, when you are sending, like you are pinging to this IP address. So what it will check? It will check the both are same network or not. Both are not same network, right? Both are in not same logical network. So they cannot able to communicate. So what it will do? It drop the packet. So it will tell it's not same network. I will show you that how the ping request will come. How to check my IP address? IP config. Okay, this is my IP address 192.168. 1.29. So what I'm doing is I'm pinging to 192.168.10.22. Okay, so I will get different kind of outcomes. So request timed out, destination host not reachable, that kind of outcomes I will get it. Okay, because it is also a private IP address, don't worry. That IP is not there. That is a with different reasons you are getting what kind of address, but in generally, I'm trying to communicate different networks. Same network also you may get same thing like 1.22. So first three portions network. Destination host not reachable. Why I'm getting here request timed out? Why I'm getting here destination host not reachable? I am getting destination host not reachable because when both are same networks, when both PCs are same network, it try to communicate within the network only, within the local network only. But of course, this PC is not available. This PC is not available. What it is doing? Destination host not reachable. Okay, when I am trying to communicate outside of my network, see this is 3 portions same, but this is 10, this is 1. Okay, so my IP address is 1, here it is, it's 10, it's a class C. First 3 portions must be same, right? First 2 are same, but third one is different. So both are different networks. So what it will do, it try to forward the packet to that default gateway. You try to forward the packet to default gateway and telling I want to communicate to this IP address. Okay, so how packet will travel? Packet is going to the PC and this is not belongs to the same network, right? So my PC will decide to forward the packet to gateway. This is the default gateway of this PC, which is configured like this, which is here, default gateway. This is trying to communicate, forward the packet to default gateway. So router understand your request, you are trying to communicate to this PC, okay? So it will search where it is located. It may be in this location, so it will forward and it will reach to this destination. Same way reverse communication, reverse side. For example, this is the PC, want to communicate this PC, okay? So what it will do, this IP address is a 1.1.1.3 is not in their local network. Both are different networks. What it will do, it forward the packet to the router because this is the default gateway of this network. For this network, this is the default gateway. So this PC having this as a default gateway will forward to their default gateway. And what router it will do? It will forward the packet towards this one and reach here. Okay, so that is the main importance of default gateway and how two different networks will communicate through the router. Okay, so that is inter-networking device. Router is inter-networking device. But important another point, first point is to communicate between two devices, both must be in the same network, means their network portion must be same. That is first. This is implemented configuration. That is two different networks are there completely. So then we have to make a communication, we use a router. Guys, look at this example. This is the PCA1, PC2. Both network IDs are same, so they will communicate each other. And PC3, again, PC3, the first two portions with the PC1 and PC2 same. So PC1, PC2, PC3 communicate each other, and PC4 cannot communicate with the PC1, PC2, PC3. Why? First portion is same, second portion is different. So identify which network portion it is. You can try it like see APC, BPC. APC first portion is same and it is a class A. So you have to check first portion. First portion is same, so both can be able to communicate each other. CPC, the first portion is different from A and B, so AB cannot communicate it to C. Okay. For example, you have a three PCs. One PC IP address is this one. Second PC, third PC IP address. You enter like this. Now you realize AB is communicating each other, but AB is not communicating with a C. AB communicating each other, but they are not able to communicate with the C. Where is the problem? C's IP address. In troubleshooting, you have to check the cross verify both IP addresses are same or different. Both IP addresses are same or different. So both IP addresses same or different means their network portion is same or not. So network portion is not same. So what you have to do it? You have to correct it.
To the router.
Go to see. Yeah, tell me.
So to the router, connected to the router.
Yeah, very good. Okay, so yeah, in this kind of network where we put a router, we can't, right? So in this one single network kind of stuff, we don't use a router. Router is a costly. Again, for that one, we don't use router. Okay, so what we will do it, we'll try to follow the same network, same logical network only. Okay, if in case, for example, here you written wrongly. For example, this is 2 dot 1 dot like this is there. No? For example, you put a 4 here. This network, these three pieces are different logical network. It's a two series. It is 2 dot 0 dot 0 dot 0 dot network. These three pieces are like that, but this is different. You put a 4 dot 7 dot 9 dot 4. This is logically different network, right? For this purpose, we cannot put router, right? For like this, every mistake you don't do it. It is a mistake. I'm not saying it is. It is there. It is simply it is. Some by mistake you enter a wrong IP. What you will do it? If it is not able to communicate, what you have to do it? You have to correct. Okay, that's the point. Okay, if three pieces are in the same physical network, two pieces are able to communicate each other, but one piece is unable to communicate. Of course, you have to check the physical connectivity, also check the IP address. If in case IP address is different network, better to change as per the existing network. Better to change as per the your network planning or a AB based on AB you can change it or based on your planning you are changing. Okay, it is not required to put a router there, but compulsory if two different networks, two different physically logically different networks are there and compulsory it is there, it is that is the structure it is there. So to make a communication between two different physically logically different networks, you want to make a communication, you will use routers. To understand that one only, I use the router only. Okay. So here also same thing, guys. Here it is. I have a totally 5 pieces. AB same network means first three portions are same because it's a class C. But here it is third portion is different. Here second portion is different. First portion is different. So any which ways, CDE cannot communicate to AB. Okay. So understand that same network are different networks. Next one is subnet mask. Next one is subnet mask. What is this subnet mask? Subnet mask will tell what is your network ID. You have an IP address. That IP address will be divided into network portion and host portion. Network IP address is divided into network portion and host portion. Using subnet mask we will do. subnet mask will divide. Okay, so subnet mask will tell you what is your network ID. Okay, so how it will work? It's based on a AND gate. Okay, even if you are not from the electronics or a CSE background of all and guys, it's a 10th class only. Okay, you know truth tables. False, 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 true, false, false, sorry, true, false, false, true, true, true. Okay, this is AND gate. So if you forget that point, I don't know, but so there is a AND or not, NAND nor, XOR, X nor, truth tables are there. Please try to go. It is very useful in your future also, like you want to become programming and or anything. So the truth tables are important. But here it is, understand AND gate. If both inputs are high, output is high, means 1 1, then 1. 1 0 or 0 1 or 0 0 becomes 0 only. Okay. And we have a default subnet mask for a class A, it is 255.0.0.0. So class B 255.255.0.0, class C 255.255.255.0. It is a default subnet mask for a class A, class B, class C. Okay. For example, you are using a class A IP address. And what is your subnet mask? By default, it is 255.0.0.0. Can you see my IP address? This is my IP address. And which class? Class C. So that's why I got a, by default, it is a class C subnet mask. Class C subnet mask. Okay. If you go through this part, what is this? Okay, I will do the attendance, no problem. Okay. Guys, actually, we can able to calculate network IDs and all, but it is not a, we don't get that much time to for. But take an IP address. I have taken IP address and their subnet mask. I want to get network ID by calculating it. So what I have done, I convert this entire IP address into binary and the subnet mask into the binary. I start doing ending. So see, it is 1 1 1 1 1 1 0 1 0 0 1 0 1 0 0, sorry, 0 1 0 0 1 0 0 1 0 0 1 0. So this part is, okay, we got it. Next, this part 1 1 1 0 1 0 1 1 1 0 1 0 1 1 1 0 1 0 0 1 0 0 1 0 0 1 0 0 1 0 0 1 0 0 1 0 1 1 1 0 1 0 1 1 1 0 1 0. See, like this 0 0 0, but these are all zeros, right? So no problem. Any, whether it is any ones or not there or not, we don't mind. So okay, so no need to mind. Anyway, we are getting a zeros. Here ones are there. So where are the ones here? That ones will become. These all zeros are there. Here ones are zeros. We'll get a zeros only. So this is your network ID. If you convert back to the decimal form, this is your network ID. So now two PCs are there. They want to communicate each other. So they will check their network ID. If network ID is same, they will communicate each other. If network ID is not same, they won't communicate each other. Okay. So one more point is here, guys. Guys, understand use of subnet mask in network and host portions. Anyone? Do you understand network and host portions at least? For class A, class B, and class C, what is network portion? What is host portion?
Not much, sir.
Very good. Then good, no problem. Not much is also you learn a lot of things. Actually, I thought no one is understanding. That's why I'm asking 2-3 times. No violence. Okay, just 1-2 examples we do it. So then we'll try. Okay. For example, I have a PC 1 APC. APC IP address is will take a different IP structures, right? Yeah, 151, 25, 36, 114. And I have another PCB. Okay, only network and host portion calculation, not the subnet mask. Okay, subnet mask also same concept, no difference in it. 151, 25, 14, 136. Which class it is first?
A class, sir. No, so B class.
B class.
Very good. No problem. That is good. Okay. So class B. Class B, first two portions are network. Next is host, right? So we have to, if you want to, like you want to ping from A to B, so can we able to communicate or not? Okay. So like AB can able to communicate or not. So what is the rule? Network portion must be same, right? So check it. First portion is network portion, same. Network, same. First portion is same. Good. Next one we will check it. Network, same. Same. Next is host portion. Host. Whatsoever it is in the host, we don't mind. Only thing is host completely not same. Like that 36.114, 36.114 should not be there. It can be 36.114, 114.36, no problem. Like it is 114.36, no problem. Okay, that is no problem. But so the portion means this is both 36, 114 are different, no problem. 114, 136, no problem. One more example to avoid one confusion in the future. This is also 25. This is also 14. 130. 113. 13 is enough. Okay. See again. Network, same. Network, same. Host is same, but host is different here. This also will communicate each other. These three will communicate each other, no problem. So that's why I given this example. Okay, maybe think like a compulsory host to host, all hosts should be different. No, not like that. Okay, one difference is also okay, like 36, 114, 37, 114, acceptable because it's like a series numbers, like a 1001, 2001. This is value is 1001. This is a 2001. Both are different. Okay, both values are different. Even it is look like a same. This is also acceptable. Guys, understand? So these pieces can communicate or not.
Yes, sir.
I'm taking another IP 200.10.5.6. Another IP 200.10.5.100. Again check it. Network. So which class it is? First of all, which class it is?
Class C.
Class C. So class C means network, host. Okay. Is the first part is same, first octet same, network same, second octet, third octet, network same. Of course, this is a host, no problem in a host. network same. 200 dot 11 dot 5 dot 110. Network same. This portion same. This portion is having difference. This network portion is having different. This is same. This is okay. So it won't communicate. So network portion must be same. If you change some one part of network portion, either it is a first or second or third, network portion is say change, you can't able to communicate. I'll come back to this 151 series. So 152, 25, 14, 14. It won't communicate. Why?
So because it is B series, B class.
Class B and
It is network, host.
yes, network, host. This network is, this portion is different from the earlier network portions. This network, this is separate network. Okay, it's different from these networks. Or you take 151, 24, 14, 15.
Not
See, it is,
communicated, sir.
there is a difference. This second place is different. Here, third place is different. See, it is, third place is different. No problem, because it's the host portion. Same or different, we don't mind it. Anyway, here is a difference is there anyway, but third place is different. So we don't mind about host portion first of all. That is later it will come, but network is same or not. If network is not same, network portion is not same, so those pieces, the pieces will communicate each other, and these pieces cannot communicate to other pieces. Okay, so each portion must be satisfied. So here it is like it. If I take 201, 10, 5, 11, 201. So first portion itself not matches, not communicated. So all three portions must be same in the class C. In a class B, first two portions must be same. Class B, first three portions must be same. In a class A, only first portion must be same. Class A, only network portion, right? So remaining are host. It means first portion same. For example, you take 10, 1, 2, 3. So this must be same. 10, 100, 200, 250. See how much difference is there? But both are in a same network because network portion is must be same. Okay. That is network and host portions. But we can understand which is the network portion, which is host portion. But how system can understand which is the network portion and what is their network ID, and whether these two pieces can, whether I can able to communicate that PC directly or not. Okay, that PC directly or not. Just like we are given some IP addresses here, like this. Is this PC can able to communicate this PC? Okay, and this PC can communicate this PC. How they will know each? How they will know can I communicate or not? Both are in the same network or not? So which one is helpful? Their subnet mask. Their subnet mask. So same thing only, it is in the subnet mask. Guys, network represent 1, host represent 0 in a binary 1. Okay, host represent in a zeros. Okay, that is again subnetting concept. So default subnet mask represent your network and host portions. Same as your default network and host portions time only. Okay, so So system, while it is communicating to other PC, the system will try to understand both are in a same network or not. If both are not in the same network, they won't communicate each other. If both are same network, so they will communicate each other. Network portion must be same. And what is this subnet mask? It tells your network ID. It divide a IP address into network portion and host portion, and it use a AND gate truth table, so like it is called a ending operation. Okay, so that is about your subnet mask. And the last point, which is I told in a starting, which is I said I will tell in the starting, that is why we need to divide in a network and host based on the network sizes, guys. So number of hosts per network, number of hosts per network is there. I'll go to that point. For example, I have taken a network 192.168.20.0. This is the starting IP, right? Start with this one, and next one is become 1, 0 become 1, 2, 3, like that keep goes 254, and last one is 255. Last in the octet is 255. Once it is last reach like a 0, 1, 2, 9. Okay, so it become 1 0. Again 19 become 2 0. 99 become 1000. 199 become 200. Sorry, 100. 199 is 200. Okay, so like this it keep going. Same kind of stuff is also there. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like 254, 255, and become 0. And 1 is will be added. This is a 21. Remaining is same, of course. That will be changed later. That is different. It is different. See, as per our network part, first 3 portions must be same, but in this one, it is different. So meaning is it is a separate network. This is my total network size. This is my total network size. The 0th one represent network ID. First one is network ID. The last one is called a broadcast ID. Last one is broadcast ID. The first means dot one is there now. If you are, so like you have 100 computers and you want to assign an IP address one by one.
They change it.
The first one, yeah, tell me.
Sir, 192.168.21.0 is connected, is communicated with 192.168.20.
No. Uh, okay, so I will tell. Okay,
But sir,
so
it is a network host, na sir.
yeah, I will tell. Okay, 1 second. Okay, this is a total one network. Okay,
Yes, sir.
out of this one, this is the first one with the dot 0. Dot 0. It's a starting IP address. This
Okay.
is called a network ID, which we cannot assign to any PC. We can't assign. That represent which network it is. That's it. So this is the dot 1 is there, no? 20.1. From here, you can assign to devices. Like you can give, this is 192.168.20.1. This is 20.2, like that. So that's why it is called a first valid IP address. Valid IP or a valid host. People use like this. Okay. So you have a computer, so you can start using, you can start assigning from here, not from here. Okay, not from here. From here, you can start using. So that's the first one. Then 20.1, 20.2, 20.3, 20.50, 20.100, up to 20.100.
55.
20.254. 1 to 254 only. Okay, this is the last valid. We can assign up to, but
20 dot.
last one is there now 255. That is a originally last. 0 is a originally first. 255 is a originally last, but not for a host, means not for a computers, not for devices. This represent network ID. This represent broadcast ID. Broadcast ID. What is a broadcast? I have a devices in the network. Okay, all are connected. Now I want to send a broadcast to everyone. Means I send a packet, so that packet will reach it to everyone, irrespective of what network, whatever it is. Like it is just turn on, they will reach the packet. Broadcast means give it to everyone. Of course, but what is this broadcast? Why we call this one as a broadcast? Within this network, for example, it is a 20.1 is there, and 20.5, 20.11, 20.20, 20.21. These PCs are there. Now this PC want to broadcast. Broadcast means when you are sending a packet, source IP, destination IP is there. Source IP is, for example, 20.1 source IP. Destination IP 20.255. Okay, source IP 20.1, destination IP 20.255 means broadcast to everyone. Broadcast to everyone, but within this same logical network only. To broadcast any packet within the same logical network, so the destination is this packet. For example, you want to send a communicate, like a source IP is 20.1 from here to 20.21. This is unicast, means this is one PC, this is the exactly a PC, so this is a unicast. But this is you are broadcasting with a broadcast IP address, means it is a broadcasting. Multicasting is different, that is completely different, but this is a broadcasting. So 2 IP addresses in the total range. So 0 to 255, and 2 IP addresses we are not using. So how many are we using? 1 to 254 only. In this network, in the class C, we use 1 to 254 only. This range is we are using. We are assigning to devices, not 0, not 255. That's why it is in one single class C network. You take any class C network, you take any class C network, you can take this is the class C network. In this class C network, these 3 portions. First, okay, these 3 portions are network portion, and if you put instead of 250 0, okay, 201.2.100.0 is a network ID, and 100.1, 100.2 like it continues. 100.255 is a broadcast. 100.254 is a last IP. So whatever the network it is in a class C, you are getting host portion is only one host portion, means it's 8 bits 2 to the power of a 256 minus 2 y minus 2 network ID and broadcast ID we are not using. So in one single class C network, you can connect up to 254 devices. In single logical network, you can connect 254 devices. Okay, up to 254 devices. For example, you have a 10 computers. You can choose class C because you are getting 254. You have 50 computers, class C. 100 computers, class C. 200 computers, class C. 300 computers. Now no class C. 300, we cross already 255. So you cannot connect 300 computers in a class
We
C.
have
You tell
we have
me?
class B, sir. If we have 300
Yes.
computers, then we will shift it to class B.
Yes, very good. Very good. Correct, correct. So you have a 300 computers. Means your class C no longer working. You have to go to, you have to redesign with a class B. You have to take IP address from class B range. You have to use the class B. Why class B? You can see there's a two host portions and a two network portions. This host portion means totally it is 8 zeros, 2 to the power of, so 0 means 8 zeros. 255 means 8 ones, 0 means 8 zeros. Totally 16 zeros means 2 octets, 2 8 bits, 2 8 bits or 2 8 zeros. It means 16 zeros, it is 2 to the power of 16 minus 2, it is 65,534 devices we can connect in a class B network. Okay, if you want, you can see 172, for example, 16. This is constant. 0.0. This is network ID. Okay, and the last one in this series 16.255.255. This is broadcast ID. Both are we can't use. What we can use it up to 16.255.254, and this is 172.16 0.1. This is the first one. This is the last one. Entire range 0.1, 0.2, 0.3, 0.254, 0.255, 1.0, 1.1, 1.2, 1.3, 1.255, 2.0, 2.1, 2.2, like that it will continue. It reach up to here. This total range is 65,534 IP addresses and plus these two. Okay, so you have a more than 300 computers, which is class B. 500 computers, class B. 1,000, 5,000, 60,000, 65,000. No problem. 70,000. Now class B is not enough. Class B is not enough. We have to move to class A. Why? 3 host portions. Each portion is 8 bits, so 24. 2 to the power of 24 minus 2, you will get a 16,777,214 IP host you can able to connect. 16 million host. Yeah, why do we do minus? Yeah, minus 2. Why should we do minus 2? Why? Because of in this is a total range. This is 256 IP addresses from 0 to 255. It is a 256. But out of this one, we are not using network ID. Not using means if you have a computer, you can't assign 20.0 or you can't assign 20.255. Both we can't assign. We can assign from 20.1, 20.2, 20.3 up to 20.254. That much we can assign, but we can't assign the first and we can't assign the last one. That's why we are doing minus 2 to get a only valid IP addresses. Means what IP addresses we can able to assign. Got it? Very good. So this is about your IP address, subnet mask, number of hosts per network information. The last, not the last part, there is so many parts are there. Okay, yeah, this is sending message. Yeah, very good. Very good. Before I go to next, Pranjal Singh Only Pranjal Singh is missing here. So all are came. Okay, guys. Yeah. Here it is. Subnetting. Anyway, we are not going to discuss about the subnetting and all. Again, it will take a lot of time, but it is a very beautiful concept. People who want to seek career in the networking side, mainly CCNA, CCNP side, you must learn the subnetting. You must learn the subnetting, but this is not a time. Okay, so it will take like completely understand subnetting. At least it will work for means 3 days of class is required. First of all, minimum 1 month of practice is required. Practice.
Okay, sir.
Subnetting is required more practice, like mathematics.
Mm-hmm.
Okay, so that's why. Okay, so like you know, there is always a competition. So like if there is a question, so they'll give you an IP address and subnet mask. They'll tell what is the network ID. What is the network ID? Like there is one websites are there for questions. You learn subnetting. Once you learn subnetting, so you have to practice by taking questions. And what is the final point? Like while you see your question, you have to tell an answer. We don't require pen and paper. For example, here it is given some network, subnetwork is giving. What is the last valid host on this subnetwork? Okay, so it is given some network, subnetwork, and given some subnet using a slash notation. Slash 20 means the subnet is 240.240.240.0. That is a subnet mask. It's a 240. Yeah, right. It is a 240, and it is a subnet. Okay, I forget. I have to practice again because I am not teaching. I forget. Yeah, it is a 16, 15. It is 172, 18, 127.254. Yeah, okay. 127.254. So like you see the question and you tell an answer. Okay. It will give questions only. No, you can relieve answer later. You see the question, you'll tell an answer. That is a point. So 23. It means 255.255.2 minus 1, right? 254.0 is a subnet mask. Okay. Which subnet does last host? It may be subnet is asking for a network ID. So 170.21 dot. Last one is 1 means it is 170.0. 170.0. Like this. Okay.
So how is it related? Please explain this well.
Yeah, if I explain, we will get world. Me and you both. Other people will die.
Okay.
People who don't understand, they will either die, they leave class, they won't come tomorrow. People who understand, they will get mad. That's the problem. Okay. So that much of power of subnetting calculation, but it's a beautiful subject. And people who want to seek the career in the networking perspective, means CCNA, CCNP, or this kind of network related part. So you can learn subnetting separately. Okay. So, but just I want to tell what it is only. Okay. See, whatever we learning about IP address, class A, class B, default subnet mask, that will be changes here. What is subnetting? Subnetting divide a IP network into multiple subnets. For example, this is a once, as I said, a single class C is giving 254 IP addresses per network, right? One single network, you are getting 254 IP addresses. If I divide this network into two parts, if I divide these two networks, this network into two parts, so each part only get 126 IP addresses. Only each part will get a 126 IP addresses, means one part up to 126 devices you can connect it, another part up to 126 devices you can able to connect. For example, this total network 254 IP addresses network, if I divide into four parts, for each part number of devices will be reduced, means like maybe 60, 64, maybe 62 per network we will get it. Okay, so why we should divide like that? Why we should divide like that, guys? In our local LAN network, we are using a private IP addresses. That is free IP addresses we are using. Okay, we want to pay to use these IP addresses. That's why you are getting 192.168 this type of network IP addresses, because you need to pay for that one. Okay, some private IP addresses are there. I will give the list. Okay, so you need to pay for using these private IP addresses, but you have to pay for using public IP addresses. Okay, so you are an organization, you want a public IP address because you have a servers. So your server want to connect to public, or you want to connect in a public directly, or maybe indirectly, whatever it is, you want a public connection, you require a public IP addresses. Okay, for example, you have a 10 servers, means you need at least 10 public IP addresses. You have a 10 servers means you require a 10 public IP addresses. Okay, so you need a 10 public IP addresses, but if you take one network minimum, like a class C, you have taken one class C, it is giving you 254 IP addresses, but you have a 10 servers only. You need a 10 public IP addresses only. So 254 minus 10, 244 IP addresses getting wasted. You have a 254 IP addresses. Out of 254, you are using 10, but you are not utilizing 244. So what happened to 244? Wasted. It is wasted. Okay, and you have to pay for all IP addresses. Wasted also you have to pay. So what is this service providers do? They will subnet the networks. Like there is a 4 or 5 clients are there. One client required 10 IP addresses. Another network required 20 IP addresses. Other person required only 5 IP addresses. Other person required a 50 IP addresses. What this service provider will do? They divide this network into small subnets. They divide a network into small subnets, multiple subnets. Okay, so whenever you divide a network into the small, whenever you divide a network into subnet, the size of the subnet is also changeable. Size of the subnet is also changes. One subnet may give you a 62 IP addresses. One subnet may 60 IP addresses. One subnet may give you 30 IP addresses only. One subnet may you get a 14 IP addresses. Some subnet you may get one subnet you may get only 2 IP addresses. In some subnet you may get a 4 IP addresses, not 4, 6 IP addresses. So minimum is 2, minimum IP addresses you will get a per subnet is 2 IP addresses, only 2 IP addresses. Okay, 2 IP addresses or 6 IP addresses or 14 IP addresses, 30 IP addresses, 62 IP addresses, 126 IP addresses, 240. Sorry, to how much said last one? 126 IP addresses, and of course 254 IP addresses. 254 IP addresses are 510 IP addresses. So how I am telling? Any calculation? This is our calculation, right? It is like this. No, not like this. Like this calculations are there. So based on that, I am telling. Meaning is 256 minus 2, 254. If you take off, like you take 128 minus 2, 64 minus 2. In that context only I told, but don't worry, guys. Very simple. To whenever you do subnet, number of hosts per subnet also changes. Next. Okay, to divide a network into subnets, we use subnet mask. We divide a network into subnets, we use subnet mask. If you use default subnet mask, that type of network we call it as a classful network. If you use a customized subnet mask, means you change your subnet mask, that is called a classless subnet mask. Guys, look at here. This is 172.16.110. It is a class B IP address. That's why subnet mask is 255.255.0.0. I am using default subnet mask. If you use this network, that is called a class full network. And you got a network ID 170.16.0.0 is a network ID. Start of network. Okay. So I am using 170.16.100.11. Both are almost same network. Both are same, right? But this second one, I changed the subnet mask. 255.255.255.0. So when you calculate, the network ID changes. 172.16.100.0 is a network ID. Now, earlier, if you use in both IP addresses same subnet mask, both will communicate each other. For if you are using like this, both are different networks now. Both are network now. How? Because of their network ID. So second one is called as a classless, because I am not using default subnet mask. I use some different subnet mask. Okay. So change of subnet to it divides the network into subnets. But what subnets it is, like you can see, not only 255, it is there is a ones kind of stuff is also there. So like a /20, I calculate /20, right? /20 means number of ones are 20 ones, remaining are zeros. Totally 32-bit. /20 means 20 ones, remaining are 0. Then you translate, then it is look like this one. You take a subnet mask, different subnet mask, like a /27 means look like this, and this is not a default one. This is not a default one, right? This is a subnet mask changed. Okay, these are the changed subnet mask, different subnet mask I am using. Based on this, we have to calculate our network and host portions, of course. So a lot of confusion is there, so don't worry. Just I will jump from there. Okay, only subnetting. Understand what is subnetting? So we divide a network into small subnets using by changing the subnet mask. So we can divide a network into small subnets, divide into multiple subnets. the subnets having the subnets, each subnet having number of hosts but lesser than a usual. Okay. So next one is, guys, how to represent this subnet mask. How to represent subnet mask. If you write an IP address, you told like, so what is your IP address? And you told an IP address 192.168.10.110 or 170.16.19.110. That's it. You didn't tell anything. Meaning is you are using default subnet mask. You are a classful network. You are using default subnet mask. If in case you change the subnet mask, compulsory you have to tell the subnet mask. Next one is either you are using default subnet mask or changed subnet mask. In some places you have to compulsory enter the subnet mask as it is. Whatever the subnet mask it is, you have to tell. Generally, if you don't tell subnet mask, in general it is you are using default subnet mask, means classful network you are using default subnet mask. Okay. If in case you change the different subnet mask than a default, compulsory you have to tell what is your subnet mask. Either way, which way, whatever the way it is, you can also tell the subnet mask in the slash notation. The slash notation. The slash notation is nothing but representing subnet mask in the slash notation. It is represents subnet mask. This method we call it as a CIDR method, classless inter-domain routing. The method is classless inter-domain routing method. Some places we call this slash notation as a prefix. Understand this. Representing subnet mask is like a prefix. Whenever you see a certain system like a Linux systems, you see it is asking a prefix, or you see the DHCP and there is a bottom it shows prefix. What is the prefix? It is nothing but a subnet mask representation only. How it is represented in a slash notation? If you convert your subnet mask into the binary, number of ones in the subnet mask, that number only we are taking. Okay, slash notation. So for example, slash n represent number of ones in the subnet mask if you are converting to binary. For example, you take 255.0.0.0, 255 means 8 ones. That's why it is slash 8. 255, 255, 8 plus 8, 16. 255, 255, 255 slash 24. 255, 255, 255, 24, 128 means 1,000,004 zeros. It means there is only one is there. So means 24 plus 1, 25. Same goes here, it is 255, 255, 240, 0. It means 255, 8, 255, 8, 244 means 16 plus 4 slash 20. It represents slash 20. 255, 255, 255, 224. 224 represent 224 having 3 ones. 224 having 3 ones means 24 plus 3, 27. So when you see a subnet mask, so you want to write in the slash notation. So 255 means 8 ones. Anything other than 255 means compulsory check this sheet. So in the subnet mask, either 0 or 255. If anything more than 0 to 250, anything other than 0 to 255, it should be either 128, 192, 224, 240, 248, 252, 240, 254. Why? It is also reason is there. Guys, all these ones from left to right. 1 1 1 1 1 1 1 1 1 1 1 1 1 1. Okay, so always left to right. In middle, you won't get any ones here. Here 1 won't happen. 0 in middle don't happen. It is always 1 1 1 1 1 1 1 1 1. And to stop here 0 0 0 0 0 0 like this only. It is not a mixer in the subnet mask. That's why that is out. I already given attendance, not problem. Okay. Guys, understand up to here? Your IP addresses, subnet mask, subnetting, and representation of subnet mask in slash notation. This is the last part. Anybody said something, then I will continue. Yeah, I will tell in 10 minutes, then we'll leave. Okay, tomorrow class is there, guys. Don't forget, morning 10:30. Any changes, I will inform. Okay, I want to tell
Okay,
about
sir.
operating system. Okay, morning 9:30. Other batch is also there.
Okay, sir.
We combinedly we'll see. Okay, IP address, private IP address, public IP address. IP addresses, private IP, public IP. Just before I told, there is a private IP we are using in our local LAN network. We are using private IP. These private IP addresses are non-routable, means in a public, these private IP are invalid. Public IP addresses are other than private IP addresses, other than reserved IP addresses, like APIPA kind of IP addresses. All remaining IP addresses are public IP only from class A, class B, class C. Other than private IP addresses and reserved IP addresses, all remaining IP addresses are public IP addresses only. So you can use, I can use, you can use without paying, without taking any permission, any range in the private IP addresses in our local LAN network. But you want to use a private public IP, you have to pay for the public IP. You have to purchase the public IP or take a lease for a public IP address. Take a lease for a public IP. Okay. So class A is a 10.0.0.0 to 10.255.255.255. Simply say 10 series, entire 10 series is your private IP. Entire 10 series is your private IP. So your IP address is 10 dot something. Okay, anything. So it meaning is you are using a private IP. Okay, you use 11. This is not only different network, it is also public. So anything complete 10 series. So network portion is 10 and whatsoever it is a completely one private network. Like this is 10.0.0.0 is a network ID. Okay, 0.1 start IP and up to 10.255, 255, 254. Last 255 is broadcast. This is the range. So very simple to understand, guys. This entire 10 series is private. Next, 172.16, this series, okay, up to 17 means 18, 19, 20, it goes up to 31. This entire part, entire series. So 172.16 or 172.17, 172.18, 172.19 or 172.31. Up to here, it is a private range only. This is one network, this is another network, this is another network, this is another network. These are different networks only. This is one network. This is completely one network. And this is completely one network. And from 16, 17th, 18, 19, like a 31. Okay, all these networks are private IP address networks only. It means 172 16.0.0 starting network, 0.1 valid, 255.254 last valid, 255 broadcast. So this entire series is one network, a private. Again start with a 17.0. Again this series also private, and this is entirely another network. Okay, so this is class B range. Class B private IP addresses and comes under class B. This is class C. That's why whenever you see your network or your friend network or anything, most of the time you can see 192. There is two reasons. One is 192.168. This series, okay, this series is completely private IP address. This can be changed. This can be changed, but this is constantly in the private network. But as per the network, different. 172, 168, 0.0 is the first network, and 0.1, 0.255 last, 254 valid last, 255 bottom last. One network completed here. Because as per network portion, this is a network portion. This also comes under network portion. This is one network, private, but one network. The new network is 1.0. This is another network. Again 1.255. Finish. 2.0, another network. Okay. So private IP range, but network ranges are different. These are the private IP address. As I said, guys, internally you have a PCs, you have a LAN network. You can use any private IP address series for your network. Okay. So irrespective of number of devices, you can use A or B or C. Okay, that is your wish. But when you want to communicate to the public, what you require? Public IP address. So your server having a private IP, and you want to get access from public. You want to get access from public. I think already I explained this NAT kind of stuff. So you have a server. The server need to be accessed from someone in the public. Like I'm accessing google.com, facebook.com. I'm accessing google.com. How? Because google.com has a public IP address, direct public IP address is there. So I can able to access it, right? Like that, I have a server. My server want to get access. So through internet, what I need a public IP address. Okay. So if I have a public IP, then I can able to get access directly. Again, so how it is, like you can contact your service provider, then ask I need a public IP. He will tell a static IP. No, not static IP. It's a static public IP, and pay to him. He will arrange that routing part, because you purchase a public, but it should be known to others. Okay. So here it is, last point, guys. In case you have a server, but it contains some private IP address. Now you want to get access. How to do it? You are in a private, but other person is want to access in a public. So what you do? You put a NAT translator or a router. You configure NAT configuration. You map your private. For example, your private is 192. I will go to this one. Okay, this is your private IP, but in public you are communicating with this IP. Means you're receiving a packet. You receive a packet with a public IP. Receive a packet with a request with a public IP. It translates to your private IP. So you got it, and while you are sending with the private IP, but it is changed to public IP like this. So in the first one, your public IP is a destination IP for this user. This is the destination IP. So this now the destination IP changes to your private. While you are sending, your source IP is your private. And after this one, your source IP is your public IP. So this person don't know your private IP or what IP you are using. This person knows only your public IP. Okay, that is a NAT, network address translation. Okay, like internal IP address to external IP address. For example, you have a 10 servers. You need a 10 public IP addresses. That is a NAT. What is NAT? You have a 10 servers. Want to access it from public, you need a 10 public IP addresses. Okay, so that is NAT. In a NAT, two NATs are there. Static NAT. This is a type of NAT is static NAT. Another NAT is dynamic NAT is there. I'm not going for that one. This is the NAT. What is PAT? Network address translation is a NAT. NAT overload. NAT is a one-to-one type, means 10 PCs, 10 private IP addresses, 10 public IP addresses. That is NAT principle. One-to-one type. One private, one public type. 10 private, 10 public type. But if in case you have a multiple private IP addresses, but you cannot go with multiple public IP addresses, you want to overload on it. You want to overload. You are using a network address translation, but you are overloading. Means multiple, like a 10 private IP addresses, but one public IP address. Okay, so using a technique with a port address, using port address mapping, we can able to overload this NAT. So that's why it is called as a port address translation or a NAT overload So how it is possible? So you are trying to communicate from your PC to outside. It is not for outside to inside, guys. Understand? This PAT technique not for someone is in the network to communicate your PC. It is not that purpose. You are in the net. You are in the your own LAN network. You want to communicate outside. You want to communicate to outside, like you want to communicate google.com, facebook.com. This technique will useful to communicate, not to get communicated, to communicate. You are sending and receiving, not you are receiving, not only receiving won't happen with this PAT. Because of this port mapping, no one knows, understand. Only this, your ISP, your routers, that only maintaining this one port address translation. What it will do while you are sending your source IP and there is some random port mapping, port number to maps your one public IP address. You are having only one public or public IP address and save port number. So when you are receiving, your ISP understand, your router understand, your router understand this mapping. So when you are receiving a packet, it will retranslate back to the original IP address. Okay. So what is NAT? Network address translation. When you are communicating from your inside to outside communication, you are communicating with the public. Okay. NAT helps to translate from your private IP to public IP. Port address translation. NAT is a one-to-one type, 10 private, 10 public type, but you have a 10 private, but you want to overload on a single public using a port mapping technique. So that is called a port address translation, also called as a NAT overload. Of course, this is the APIPA and other parts also there. Yeah, completed. Yeah, successfully your IP address is completed, guys. How many people are You able to understand or already got headache and all? I don't know. Any questions or anything, guys?
No, sir.
Okay, okay. I stop recording, guys.